there are some rules that follow from the axioms. They are not themselves axioms. They're consequences of the axioms. They're true. They have to be true. They're always true. They're true as math facts that you can derive from the axioms, but they are not themselves axioms. They're consequences. Now, one of those consequences is that the chance of the complement of an event is 100% minus the chance of the event. Okay, so I claim that you can derive that from the axioms. How do you do that? Well, we can write, if for any set A whatsoever, the outcome space is A union the complement of A. Right? Something is either in A or it isn't in A. Those are the only possibilities. Okay? So A union A complement is S. Moreover, A intersect A complement is empty. Right? Nothing can be both in A and not in A at the same time. Yes? So according to the third axiom, the chance of A union A complement is the chance of A plus the chance of A complement. Right? But A union A complement is S. The chance of A union A complement is the chance of S. That's 100%. But because A and A complement are disjoint, the chance of A union A complement is the chance of A plus the chance of A complement. So what do we have? The chance of A plus the chance of A complement is 100%. Just subtract P of A from both sides. You get the chance of A complement. For convenience, often, that if we want to calculate the chance of an event, it can often be much, much, much simpler to calculate the chance of the complement of the event and then subtract that from 1, rather than to calculate the chance of the original event. This is typically the case if we're looking at the probability of at least one or not all or something like that. So example that's in the text is, suppose I toss, let's look at what we just did for the deck of cards. What's the chance that the top card is not the king of hearts? Well-shuffled deck, 52 factorial possible orderings, uniform distribution on those orderings. What's the chance the top card isn't the king of hearts? All right, using the complement rule, right? Chance top card not the king of hearts is 1 minus the chance the top card is king of hearts. Right? Okay. What if we wanted to do it from scratch? Well, what's the chance the top card isn't the king of hearts? Well, we could divide that up and say, okay, that's the chance the top card is the ace of spades, or the 2 of spades, or the 3 of spades, or the 4 of spades, or blah, 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 right? There are 51 possibilities that are not the king of hearts. Those 51 possibilities are mutually exclusive, because if the top card is the ace of spades, the top card is not the 2 of spades, right? So we could add the chances of each of those possibilities to find the chance of their union, the chance that the top card is anything but the king of spades. Each of those things, what's the chance the top card is the ace of spades? Did I say, I meant king of hearts. I think I said king of spades. What's the chance that the top card is the ace of spades? Okay. A few minutes ago, we agreed that the chance the top card is any particular card is 1 out of 52. Right? Okay, so chance that it's the ace of spades is 1 out of 52. Chances the 2 of spades is 1 out of 52. Chances the 3 of spades is 1 out of 52. Right? We add up all of those possibilities, but not the king of spades. So we'd get 1 out of 52 plus 1 out of 52 plus 1 out of 52 51 times. So that would give us 51 over 52. This is easier. Okay. All right, so complement rule can definitely help.